Hello, and welcome to Backer Breaks It Down. In this episode, we are going to be modeling with exponential and linear functions. I know what you're thinking. How do you know whether you should write an exponential or a linear function? And that's a really good question. Okay, linear functions make sense when you have a constant rate of change. Okay, exponentials, we're going to use those when we have a percent rate of change. Okay, so linear functions, constant rate of change, exponentials, percent rate of change. Are you ready to identify these? Well, too bad, because examples 1 through 3 want us to determine linear or exponential. That's it. So number 1, it says Allie reads at a rate of 25 pages each hour. 25 pages. That's a constant rate of change, which makes number 1 best represented with a linear function. All right, so problem 2. An investment account with an initial balance of $100 earns 3% interest each year. That's a percent rate of change. So number 2 is an exponential function. And then in number 3, Connor receives a monthly allowance of $75 and spends $15 each week. $15 each week, that's a constant rate of change. So number 3 is a linear function. Sometimes they just tell us to. Okay, so let's write a linear and an exponential function. When we write linear functions over the form y equals mx plus b. M is representing that constant rate of change, and b is the initial value. When we write exponential functions, they're going to look like this, where r is representing that percent. Got to turn it into a decimal. And then a is the initial value. So in problem number 4, let's read this. In 2007, Lucky Brand Jeans advertised their Socialite jean for $118. Write a function that represents the cost C in terms of W weeks if the price is reduced by the given amount per week. Find the cost of a pair of jeans in 5 weeks. So in part A, it says $10 per week. So $10 per week. You're right. $10 is a constant rate of change, right? So we're talking linear. So what will be the value of M here? Well, remember, the price is being reduced by $10 each week. So M will be negative 10. And what about B, the initial value? 118 is correct. So for the scenario of $10 per week, we're looking at the cost C is equal to, and if we want, we could write the initial value first, because I think that makes sense, minus 10 times W for weeks. Now the directions did ask us to find the price after 5 weeks. So what is C of 5? So if we were to substitute 5 in for W and calculate, we would get $68. Great. Let's check out the next scenario. 10% per week. You're right. That's a percent rate, so it's an exponential function. So we know that R is equal to 10%, but we need to write that as a decimal. So we're looking at 0.100 for R, and our initial value is still 118. Now I do expect you to do the math, okay? So in this scenario, when it comes to like, what is the base of this function? Since it's being reduced, this is decay. So I'm going to go 1 minus 0.10. So I'm looking at a b value of 0.9. So then I write my function. C is equal to 118 times 0.9 to the W power. And once again, I want to calculate the cost after 5 weeks. So I'm going to substitute 5 into the function, put that into my calculator, And we get approximately $69.68. So to summarize, linear functions have a constant rate of change. M is representing that constant rate of change. B is the initial value. Exponential functions have a percent rate of change. R is representing that percent rate. A is the initial value. And that is how Bakker breaks it down.